Download this code from codegive.com, link in the description below. There's no standard or widely recognized error message like 105,029 sanitizer internal defs.h 25472 error size of array related to sanitizers, like address sanitizer, memory sanitizer, undefined behavior sanitizer, etc., in C/C++. The error number and specific file, defs.h, and line numbers suggest a compiler-specific or perhaps a custom sanitizer implementation. Standard sanitizer error messages usually provide far more context, including the location of the offending code. However, I can address the core issue the error message likely points to: array size errors in relation to sanitizers. Sanitizers often detect problems stemming from accessing arrays outside their bounds, buffer overflows/underflows. Let's explore how this happens, how sanitizers detect it, and how to prevent it. Understanding array bounds and out-of-bounds access. In C and C++, arrays are contiguous blocks of memory. When you declare an array, the compiler allocates space for 5 integers. Valid indices for accessing elements are 0, 1, 2, 3, and 4. Trying to access myArray 5, or any index less than 0 or greater than 4, leads to undefined behavior. This means the program can crash, produce incorrect results, or seemingly work fine until it mysteriously fails later. How sanitizers detect array out-of-bounds access. Address sanitizer, ASAN, and other memory sanitizers instrument your code to detect out-of-bounds accesses at runtime. They typically work by 1. Memory red zones *. They allocate extra memory, red zones, before and after your array. Accessing this extra memory triggers a runtime error, indicating an out-of-bounds access. 2. Shadow memory *. They maintain a separate shadow memory that tracks the validity of memory regions. When you access an array element, the sanitizer checks the shadow memory to see if the access is valid. Example code demonstrating the problem. Let's create a program that demonstrates an out-of-bounds access and how a sanitizer would, likely, detect it. Compiling and running with sanitizers, example using Clang. To compile with address sanitizer using Clang. When you run this, ASAN will likely report an error indicating the out-of-bounds access. The exact message will vary depending on your sanitizer and compiler. The error message may mention the file name, line number, and the type of error. It might look something like this, though the specifics will differ. Preventing array out-of-bounds access. The key is careful array indexing. Always ensure your index is within the valid range. 1. Bounds checking * explicitly check the index before accessing the array. 2. Using std vector. C++ std vector is a dynamic array that automatically handles memory management and bounds checking, at least to some degree. It's generally safer than raw arrays. 3. Static analysis * use static analysis tools to detect potential out-of-bounds accesses during compilation. These tools can often find errors that sanitizers might miss. 4. Code reviews * thoroughly review your code to identify potential array access errors. By employing these techniques, you can significantly reduce the risk of array out-of-bounds errors and the related problems they can cause. Remember that the original error message might be specific to your environment, providing more context. Compiler, sanitizer version, the complete error message, would allow for a more precise analysis.